Hi students, Professor Fernetovich here, and we're discussing properties of water. The four main properties of water are that water is cohesive, that water moderates temperature, water is a good insulator, and water is a good solvent. I'm here to talk to you about moderation of temperature today because I think this is the most complicated property of water. It has to do with hydrogen bonding. So let me explain. First off, water has a high heat capacity. That means that when you heat water, it doesn't increase temperature as quickly as other liquids. It has a high capacity to hold heat. So when you apply heat to a liquid, or a solid, or a gas, any substance, it increases the movement of molecules. All molecules are in constant motion, but when you heat them up, you cause the molecules to move faster. You can measure that speed and movement of molecules with temperature. That's what temperature is a measurement of. Heat is measured in calories. So you can apply heat calories to water, and that will cause the water molecules to move around faster, increasing the temperature. However, when you apply heat to water, the hydrogen bonds between the water molecules restrain the water molecules and keep them from bouncing as fast as they otherwise would bounce. So water can hold that heat without the temperature going up as much as other liquids. Consider oil. If you've ever deep fried or heated up oil, you know you can get oil really hot on the stove. You can only get water to 212 degrees on the stove, but you can get oil to 350, 400 degrees if you apply the same amount of heat. And that's because oil molecules do not have hydrogen bonds between them. So as you increase the heat of oil, the oil molecules will bounce very rapidly, very rapidly, and the temperature will rise. It'll rise higher and higher, and oil will have this high boiling point compared to water. Water, as you apply the same amount of heat, doesn't bounce as quickly because those hydrogen bonds act like little leashes holding the molecules together. So they will bounce back and forth and temperature will rise slowly and only get to 212 Fahrenheit or 100 Celsius. As we get to that boiling point, we're applying heat. And water's specific heat is 1 calorie. That means that it takes 1 calorie worth of heat energy to raise 1 gram of water, a small amount, 1 degree Celsius. So 1 calorie raises the temperature of this small amount of water 1 degree. And we can go from 90 to 91 degrees with 1 calorie, 91 to 92, 1 calorie of heat. And as we approach the boiling point, we see something happen. 98 to 99, 1 calorie of heat. 99 to 100, about a calorie of heat. But to break that boiling point, to go above 100 degrees to the point of vaporization for water, we have to apply a lot more heat. It's about 540 calories worth of heat energy to break the hydrogen bonds between water and allow water to vaporize. Okay, so some people say a watch pot never boils, and I think that has this molecular reasoning behind it, because you can heat up water, and heating water takes time, and we're adding heat to the water. The temperature's going up, but to boil it, to get just beyond the liquid water stage, we need a lot more heat, and water has to absorb that heat. It's pretty interesting. Those hydrogen bonds have to break to release water molecules as steam and water vapor. This is why sweating and panting cools organisms. Okay, so this is an interesting property of water, but let's look at how it relates to life. So when you sweat, water acquires at the surface of your skin. Okay, water is pulled out of your body, it sits on the surface of your skin. And what happens to that water? It doesn't just sit there forever, it evaporates. It vaporizes. So when water does that, the hydrogen bonds need to break. That takes a lot of heat energy, calories energy. And that energy gets drawn from your body. So as your sweat evaporates, it cools you off, not because the surrounding air is cool, but because to vaporize the water, it takes energy. Okay, same thing with panting for dogs. The dog's tongue will stick out and the water will evaporate, cooling the dog. Okay. This works best when humidity is low, and that's because there are less water molecules present in the air around us. So when the water vaporizes, goes from a high concentration to a low concentration in the air, that vaporization can happen rapidly. If it's very humid out, the water will stay on the surface of the skin a little bit longer because it doesn't have much space to evaporate to. So that's why they say it's not the heat, it's the humidity, because when there's a lot of humidity, vaporization doesn't happen as quickly, and that heat energy can't be taken from your body. Okay, so continue to look at the PowerPoint posted on Moodle to see the other properties of water and how they're explained.